Hey everybody, this is Mr. Beckstrom, and today I want to answer a couple of the questions from the forums. Alright, the first one was, it says determine the amplitude and the phase shift for the function y equals negative sine x and sketch at least one cycle of the graph. Identify 5 points on the graph. Alright, so for this one here, the main part of this is we really need to know what does y equals sine of x look like, and then know what that negative kind of does to that. So what does just the y equals sine of x look like? And if we have kind of a graph here, I know this doesn't look very pretty, but we have 0 here, we got pi over 2, we got pi, and we have 3 pi over 2. And finally over here we have 2 pi. And up here on the y values we have 1, and down here we have a negative 1. We can actually use our unit circle to help us graph this, but the normal y equals sine of x. So the first thing I'm going to do is just graph the normal function here, y equals sine of x. And remember, I can just use it in my graph. So when x is equal to 0, or your angle is equal to 0, your so look at your unit circle there, then your value is also equal to 0, right? And then when your angle or your x value is equal to pi over 2, and you can use your x value as your angle, then your corresponding value there is going to be equal to 1. And then when your angle is equal to pi, which we're using for x values, your value there is equal to y value is equal to pi, and then it goes to negative 1, and then it goes to 2 pi, and it's going to look something like this. Right, and this is going to keep repeating. It's going to kind of go, very good here. Right, keep going on and on forever. All right, so how does y equal, let's do that in red, how does y equal negative sine x change that? Well, let's do a table for that one. So if I did a table here, and I did my x and my y values here for this, and I'm going to use my same values, so 0, pi over 2, pi, 3 pi over 2, and 2 pi down here, and let's see what happens. 0, I still get 0, right? Let's see what happens when I put in a pi over 2. The sine of pi over 2 is normally 1, and then I make it a negative, so that means it's at negative 1. So that's going to be down here. The sine of pi is 0, making it a negative 0, still going to be a 0. The sine of 3 pi over 2 is a negative 1, so making that a negative will make it a positive 1, and this will be a 0. So it's going to be there, and then here. So it looks like it's just going to reflect this across the x-axis there, just like so. And you can use your calculator to go ahead and verify that. And then to sketch at least 5 points, I could use these 5 points right here. So that's the first question there. I hope this part helped. This is using a table, and this is kind of using a visual there, albeit a crude one. That's how I go about this one. All right, let's take a look at this second one here. Second one there. And remember, when we're doing that, we're using the angles as our x values and then the actual values as our y values. The constants as our y values. All right, the second part says a printing press has a roller with a 16-inch diameter. So let's get that. Change it back to black. See if I can do ink to shape. There we go. A roller with a 16-inch diameter. So 16 inches. The speed of a point on the roller surface is 100 feet per second. So that speed going around it is 100 feet per second. Feet per second. All right. What is the roller's angular velocity? What is the roller's angular velocity? All right. So the angular velocity, and the formula for the angular velocity is this. Oops. Let me that. And the angular velocity is equal to the angle angle over the time. So what angle did it go over the amount of time it took to go that angle? That's the central angle there over the amount of time. So we really don't know how many circles it went, right, over how much time, because it really just kind of gives us speed here. So we really kind of have to use kind of another method in order to find this. And we do have another theorem here, the linear velocity in terms of angular velocity. So we know that the linear velocity is equal to the radius times the angular velocity. So how can we use that? Well, that means that if we just divide both sides by the radius there, that means our angular velocity is actually also equal to our linear velocity over our radius. And that's what we're going to use really in order to solve this one. So in this case, this is how we're going to solve it. Our linear velocity, which is what they're asking for, is going to be this is our angular velocity, excuse me, it's going to be our linear velocity, and that is our speed, 100 feet per second. But notice that this is in feet and this is inches, and we're going to need to get those in the same units, and they're actually asking for the answer to be in what are they asking for it to be? I think they want it in inches per second when they actually ask if in excuse me, I'm stuttering here. In my math lab, they want it in inches per second, so we're going to need to convert this feet into inches. So in order to do that, let me do that off to the side here. So 100 feet per 1 second times, and we can do 12 inches over 1 foot. Remember, we put the feet on the bottom because we're trying to get out of feet and into inches, and that will give us 100 times 12, which is going to be 1200. 1200 feet per 1 second. 1 second. Right? 12 times 100 is 1200 feet per 1 second. So here is our linear velocity in terms of, oops, that should be inches right there. Excuse me. Should be inches. Let me correct that. Inches per 1 second there. All right, so now we're using this formula here. So on the top we have the linear velocity, which is 1200 inches for every 1 second. And on the bottom, we need the radius. The radius is half the distance of the circle. They give us the diameter, which is the whole distance, so the radius is just half of that. So that would be over 8 inches. All right. Now we have fractions over fractions, so I can just multiply the top, 1200 inches over 1 second. All right, let me make that a little bit clearer. Times, and I'm just going to flip the 8, so 8 is really just 1 over 8 inches. All right, and so this is going to just be 1200 divided by 8. So clear, 1200 divided by 8. And I'm going to get 150. So this was going to be 150. And that should end up being, let's see, the inches cancel out. And we should get radians per second. Radians per second. And that should be our final answer for our angular velocity. All right. If you have any questions, let me know, and I hope you have a great rest of your weekend. Thanks.